right. Okay, louder. All right, so yeah, today I'm talking about AI for everybody. And all right, here we go. Yes, it's working. Wait. So first, my name is Feather Ni, and I work at NVIDIA on a special project. We're building an application that supports AI in the cloud on a cloud GPU server. And why am I talking about this at React Rally? It's because the part I'm writing is written in React. So as far as I know, this is the first application that's built in React of its kind. And it's a really cool project, so I'm pretty excited to talk about it. So my agenda for today, first I'll give you a little intro to AI, and we'll talk about some kind of like definitions and stuff. And then we'll do the React part, and then we'll have some conclusions. So what is AI? It's something that people kind of talk about a lot, and I think the definition is a little fuzzy for a lot of us. But basically, as software engineers, we're kind of used to our code doing exactly what we tell it to, right? Sometimes it's not what we intended to tell it to do, but it pretty much does what we tell it to. So an AI is that point at which our code starts making decisions independently of us. And it's kind of a blanket term for a lot of different things. So sort of like within that umbrella of AI, you have machine learning, you have deep learning, convolutional neural networks, and all kinds of other things that are really hard to say and even harder to describe kind of fall under that umbrella of AI. So there's actually quite a lot of history behind this term as well. And this is something I didn't really realize kind of before starting to put this talk together. But the term goes back to the 50s, which is a lot further back than I would have thought. And if you kind of look at the history of AI, there's this like decades of just sort of like fascination and wild imaginings that went along with a lot of like spectacular failure, because there just wasn't the hardware to sort of support the vision and the ideas. And sort of what's happened recently is that we've had a lot of kind of big breakthroughs in technology, and AI has just sort of exploded into all these different directions. So like today, we've got passive collection of data on this massive scale. We've got the graphics processing unit, which is this, it's kind of like most of the machines that we work on have a CPU, and the GPU is kind of different in that it sort of spreads out the processing to more units, and each unit does a little bit less work. And that was originally developed around gaming, but it turns out that it's really good for machine learning and other kinds of like very computationally intensive tasks. And so this has kind of led to the acceleration of AI in every area. And I kind of like to think of this like as a gardener. Like I have moments where I'm gardening where all of a sudden I just have like so many zucchinis. And so I'm making zucchini bread. I'm like making zucchini muffins. I'm making zoodles, you know, the zucchini noodles. And so it's just like I've got like the ingredients, so I just put it in everything. I kind of feel like that's the way it's becoming with AI. Like it's just going into all these different areas because we have the ingredients. So I think a lot of people are kind of asking this question, which is, should we be afraid? And I think it's a legitimate question. I mean, definitely don't be afraid of this guy because he's just here to dance. But so back in the 80s, there was this vision of 2019. I don't know how many of you recognize this. All right, yeah. So like 3 of you apparently. Nobody's ever seen Blade Runner. The original Blade Runner. Probably those of you who are closer to my age than the younger ones. So in sort of like in the Blade Runner vision of the world, you have these replicants that are indistinguishable from human beings. And they're kind of terrifying because they could just look and act exactly like a human being, but they're actually a robot, and I don't know. So in 2018, we actually do have robots kind of like in our daily lives. Like, how many of you own a Roomba? I have a Roomba. It's great. My dog is always like, what the hell is this thing? But it's really efficient. So there's this really scary new robot that got developed, and it it can assemble an IKEA chair in just under 9 minutes, which is terrifying. It took 3 years for them to program this robot to do this. And I don't think this robot is really fooling anybody. Like, there's no test required. We know it's a robot. So I don't think that the real thing that's scary are that we're going to have these kind of robots that look just like us replacing us. I think it's more terrifying that AI is already everywhere, and it's been kind of like this quiet storm, thanks Sade, that's kind of crept into our world. And I think in a lot of ways haven't really realized it. It's very pervasive. I found this article in the New Yorker. And by the way, if you're interested in sort of like some of the sort of more social ramifications of AI, the New Yorker is an amazing source for this. So yeah, AI is very ubiquitous. We use it every day in our lives, and we don't even think about it. And that's partly because we have all of those ingredients. So we've got the piles of data. There's just, everything is digitized. All the data that's being collected on the internet, there's digitized data everywhere. We have this processing power, the amazing kind of breakthroughs that we have in that area, as well as this sort of like mathematical advances that have happened in the last few decades. That's kind of more happened in academia, but it's sort of going everywhere now too. So we have a lot of data, but sometimes we don't have a lot of like the right quality of data, and we're not really thinking about data sometimes. So just to illustrate, I want to tell you a data story. So suppose that I'm a fabulous chair designer, and I've been hired to design the perfect chair for this room. And being sort of data-driven, I'm just going to look around from my giraffe-like height and scan and just see all the people that, like me, are extremely tall. And I'll just design this chair that's amazing for tall people. And then anybody who's kind of not super tall is just going to be very uncomfortable in this chair. So that's just kind of like a small story. But on a larger scale, when you think about like getting approved for a home loan, getting loans for education, being accepted into university, suppose you've been convicted of a crime. There are decisions being made that are kind of have a lot more social ramifications. So I think those questions, they don't really belong here, but I think they need to be revisited. So let's talk about how machines learn. It's kind of mysterious, I think. I don't know. It was very fascinating to me to sort of understand how this works. So basically, it's modeled on the way that humans learn. It's not terribly different. We kind of have this feedback loop where we learn through our experiences. We try things, our eyes tell us things, our experiences tell us things, and we iterate, and we kind of learn that way. And so for people who have bodies, a lot of this input is sensory. But for machines, it's data, and it's a mathematical feedback loop. So if you think about, like, this is some of the kind of like math behind this. If you think about like a snapshot, it's like a digital snapshot is kind of like a collection of values. It's a matrix of values, if you will. There are coordinates on a plane that have a certain color and a location, right? So you can do transformations on those values, and kind of the rule is that all those values have to change sort of in a similar way together. And after each one of those kind of transformation layers, there's a feedback loop, there's a learning that happens for the machine. And I'll show you kind of how this works. It's a little bit strange. So what is this? Anybody know? All right. I know you guys aren't toddlers because you knew right away that was a cow. So, so a toddler, like a baby, when they first see a cow, they have no idea how to put words around that. They're kind of just learning for the first time, and their sensory feedback is kind of like they've maybe seen 1 or 2 cows in their whole lives. And by this point in your life, you know that it's a cow, even if it's a cow wearing a hat. you're kind of able to recognize cows in all types of situations. Cow situations. So a machine can just see thousands of cows per second. So you can kind of train that very quickly. And this very same logic applies with a model that would recognize faces. You can even use this. I actually ran my dogs, like images of my dogs, through a learning algorithm that was specifically about identifying breeds of animals. And it's pretty crazy. I have 2 little dogs that are just mutts, and we have no idea what breed they are. But the model knew right away that they were small dogs and kind of like zoomed in very quickly. And so that was a little strange. So if you think about a photograph of a face, again, it's a matrix of values, right? And so if you skew that matrix, it would show the face kind of turning sideways. And so when you start to train that model, it can start to recognize a face, the same face, even if it's turned sideways, or if it's in different light, or if it's in different situations. And then if you're posting these photos and you're getting kind of this instant feedback all the time, like on Facebook, where you have like millions of people tagging photos, then that model gets to a high degree of accuracy really quickly. So in conclusion, robots probably not going to take over the world next year. I think AI is already everywhere. And the real threat, I think, if we're going to be afraid of anything, it's that we stop thinking for ourselves and sort of asking some of the more hard questions. So now for the React part. So this is the basic architecture of my application that we're working on. So you have sort of the web interface, which is the React part. And it's talking to this API, which has a CLI tool, by the way. So you can kind of interface with that through the command line if you want. Most people prefer the web interface because it's more friendly. And those sort of communicate with this huge collection of machine learning libraries. And then you've got like the brain bucket, the GPU, that's just like the brains. And then all of that can just kind of like do some processing and then spit some things into this like basket. Like we just hold things in a wicker basket because that's where you keep data. And and then the results are going to pop out on the user interface, the screen. So, so the goals of our web application is to make AI accessible for a wider audience. So we're trying to make it very kind of approachable. The shared GPU server kind of makes it more financially approachable. Like right now, our application is being used by a lot of grad students and people who couldn't normally sort of afford these big fancy GPU servers. And it's also to build a framework agnostic platform. So you can use whatever machine learning library works the best for the type of experiments you want to do. So there's different people have developed libraries that are really, really good for different things. Like Facebook has this whole kind of like facial recognition system that's pretty amazing. So the architecture of our React application is we have modules organized by functionality. And we have so many R's. We've got Redux, RxJS, Recompose. We've got reselect, Jest, and Flow, because there's other letters in the alphabet. And our code is very functional. It's a very functional code base. And this actually was kind of new for me. I sort of came into this project not having really experienced this level of functional coding. So it's been really exciting to kind of learn these new patterns. One of my favorite things that I've learned about is Recompose. How many of you use Recompose? Just curious. All right, small handful. Cool. So Recompose is kind of like a functional tool belt, and it gives you really neat sort of like helper methods for making your code very functional. So how many of you kind of prefer stateless functional components, if you can? And have you ever felt the pain of taking your stateless functional component and having to turn it into a class component because you had to add state? And it's kind of a drag, right? Yeah. So what if I told you you never had to do that again? If you use Recompose, you never have to do that again. And I'll show you how. So it also sets you up really nicely for working with Redux if you're going to add Redux into your component. So this is your classic kind of React counter. We've all written this. It's kind of like the hello world of React applications. I don't know why, but the counter became very popular in the React community. So you have the your handler function. You have your render component, render method with your JSX in it. But this is your counter. So I'm countering the other counter with this counter. So that's why it's a counter. Anyway, so this is with Recompose. And so you can see that I have still a stateless functional component. And I'm using compose to pass in my state variables and my handlers. And so it's kind of like this crazy upside down view of the world where state becomes props and your props get passed in to your stateless functional component as props. And it's actually really nice because you kind of don't have to worry about wrapping your set state in a function to avoid race conditions or any of that. You just kind of get all that for free. And it's very clean. The other thing I like about it is we use a lot of RxJS in our application. And Recompose gives you kind of nice little helper methods for using RxJS. The other thing about it is it's really flexible. So if you want to just use an observable but not RxJS, you can use your observable of choice. It gives you a way to map your kind of observable stream to your Rack nodes. And so now I'm going to hit you with the counter, in which we use a component from stream, and your increment and decrement buttons are being wrapped with observables, and yeah. So this is kind of really overkill for an example like this. But if you're writing something like a type ahead search, it's an amazing kind of time saver and makes it really nice and clean. I got really excited about this. I got so excited I wrote a blog post. So if you want more information, feel free to check that out. There's even code samples and GitHub repos and stuff. Another thing that we're using that I really like is reselect. So how many of you ever done Ember before? 3 of you. OK, cool. So Ember has this cool thing called computed properties. So reselect is kind of if you're using Redux, reselect gives you a very similar thing to computed property. It's this memoized selector where you can just kind of grab things from the store. Or is anybody using reselect here, actually? Oh, OK, more of you. That's cool. So yeah, I really like reselect. It's just, it's very clean. It's very efficient. And you don't have to do all that dot chaining, which is kind of ugly. So this is just a simple example of creating a selector. So suppose if you have a shopping cart and you're just have a running total of your items in your shopping cart, but you don't want to recalculate that value every time somebody moves around to a different page. You can just have that sort of selector there, and it's just very convenient. So the way that we're using it a lot is we actually use it a lot with things like compose, and we'll kind of have these, we'll pass in these actions. And there's a lot of prop spreading. How many of you love prop spreading? OK. I have very strong feelings about prop spreading. I feel like it's kind of like that gift you didn't want sometimes. So it is very clean and functional. But on the other hand, it can be really confusing because you have to try to figure out what the hell is being passed in. And it's also, if your application needs to be very efficient, it is less efficient. So that's something to be aware of. So we made some more good choices. We're using flow typing. We're using Jest as our testing platform. And we're using Lodash FP. So Flow is funny. At first when I started using Flow, I really felt like I was not having much flow, if that makes sense. It was just kind of slowing me down, and I was like, ugh. But after a while, you get this kind of passive form of testing for free. And it sort of gives you this really useful feedback, like, hey, did you really mean to put a string in there? And I kind of think about it like, you know, as somebody sort of just helpfully asking you, like, are you sure that's what you wanted? This is my first application using Jest as our complete testing platform, and I really, really liked it. It's just so easy to get up and running. It's very familiar if you've done Mocha or Jasmine or whatever. And one of the things I like about it is you have all these things that are kind of just built in, like you don't ever have to use sign-in if you don't want to. Also, I love snapshots. They're so great. Yeah, snapshots just give you these kind of like pretty easy, effortless tests without really too much effort. I think I said effort twice, but you get the point. So we've learned some things. One of the things, if you're doing a lot of kind of like wrapping your components in layers of functions, you can end up with that sort of like flying V formation if you look at your sort of debugger tools. So Recompose gives you this really helpful thing called set display name, which can help you kind of like identify which component you're looking at. Another thing, we got very enthusiastic about snapshots, and then we realized that our tests were running slower and slower and slower. And so on our team, we've kind of made it a hard rule, like if you're going to mount a component, don't snapshot it. Also, do or do not flow. There's no there's no try. It's just like if you're gonna opt in to flow, like really go for it. But if not, then just don't do it. So Lodash FP is it's kind of like functional training wheels. There's also a compose with Lodash FP. So I'll be honest that when I first saw that in the code base, I was kind of like, wait, there's this compose and there's that compose. What? So basically, it gives you sort of a very declarative, clean way of using some of the Lodash operators. But instead of dot chaining them, you compose them. So you can be like a crazy composer, just start calling yourself Beethoven. I don't know. So like, if you want to create a selector to get user stuff, and this, by the way, is not a thing we're actually doing in our code base, but I couldn't show you real code, but you see this kind of pattern a lot, where you create a selector, and then inside the selector, you're using compose to just kind of stack all of your operators and pass things in, and then you just kind of have this, user stuff sitting there ready for you. So in conclusion, I really like functional patterns. This is, like I said, it's probably one of the most big and complex React applications that I've personally worked on. And I find that these functional patterns kind of help you achieve a lot of simplicity at scale. And compose all the things. And also really lean into testing early and often. Even we're still in beta testing, so we've had a lot of code that we write and then we just kind of throw out. But we've really kind of found as a team over and over again that tests are important. So I owe some thank yous. First of all, thank you to React Rally for having me. This has been just a total pleasure. Thanks. I also want to thank my team at NVIDIA, my awesome team, especially my awesome designer who beautified all of my slides. Like, you guys would have had serious eyeball pain if it were not for Josh. So thank you, Josh. I also would like to thank all the people who sat through various iterations of my talk and gave me really useful feedback and kept me from just like spouting a bunch of gibberish. So I'm at Feather Art on Twitter and pretty much like everywhere else in the world. If you have any questions, feel free to reach out to me, or I don't bite, you can talk to me on break or whatever. So thank you.